Safe morning all. So we'll start the webinar on the significance of safety and fire engineering. So the first point about the safety is nothing but it is a condition of being safe from undergoing or causing a hurt or injury or loss. That means everybody want to be safe, everybody want to be comfortable, or everybody want to free from the conditions that can lead to a death or injury or any type of occupational illness, damage or loss of equipment or property. In industrial context, we can say safety is nothing but minimization of contact between a human and a hazard. Or we can say it is predominantly concerned with prevention of a physical harm or injury to persons or property. We can go to the history of safety. History of safety is very old. We have an Indian origin. Our Vedas, especially Ramayana, Mahabharata, Kautilya's Arthashastra, they provide a valuable advice on industrial matters. Especially the basic concept of safety for human protection was explained in Rigveda. It is written here, the Puman Pumamsu Paripadu Vishwat. It is a Sanskrit word. The meaning is, let man protects man everywhere in the world. It is also said that Dharmo Rechidi Rechidha. It is also a Sanskrit word. The meaning is, Dharma, a divine force to govern all people by self-discipline, will protect them who protect themselves. So this is the primary duty of all of us, to protect ourselves. As a human being, we have to take care of all people, all fellow beings. Fellow beings we have to protect. This is the foundation of safety philosophy. Now, if we come to some Upanishad says that, one Upanishad, Sarvobhadi Sukhina Santu Sarve Santu Niramaya Sarve Bhadrani Pashyantu Ma Kashyedu Dukhapanamitu. The meaning is, let all be happy and healthy. Let all achieve welfare and no one gets an unhappiness. You know, the happiest country in the world is, according to United Nations Human Development Index, the happiest country in the world is Finland. If you take the ranking of HDA index ranking, Finland, Denmark, Norway, Iceland, Netherlands, Switzerland, Sweden, New Zealand, Austria, Australia, these are the countries which are ranked up to 10 or up to 15th HDA ranking. These are the countries. They're very happy. The people are very happy. What are the factors which affect the happiness of the people? The standard of living is one factor. The environment pollution is very factor. The education is another factor. And a safe working place and safe environment is another factor. So happiness cannot be achieved without safety and good health. So it is a prime important. Therefore, the above Sanskrit stanza speaks about safety, health, and welfare of all, which is also the modern concept of all safety law. If we come to the history of safety in foreign origin, it has started around 3000 BC, the Ebers Papyrus, the first written document on health and safety. If you come to 2000 BC, the Babylonian Code of Hammurabi, he has quoted around 280 paragraphs covers bodily injury and workers' compensation law. Lombardy King Rothari in the 7th century codified the existing laws in 388 chapters. And again, you will read Schellenberg in 1473 warned about hazard of metal burning in 1473 itself. And again, George Agricola's book in 1561 described about the air venting. And we know the industrialization in Britain, Great Britain, happened in 18th century. That is the beginning of actually the safety culture and safety law, safety inspectorate. The England government factory inspectorate was established in 1833. After so many industries have started, then only more accidents has happened. So people has given more importance to safety to protect people, protect the environment, protect the health of people. Great Factory Act was enacted in 1844 to provide fencing for mill gears and shafts. Again, George Stephenson, we know the person who found out the steam engine. He suggested the use of steam whistle for locomotives. When locomotives comes, the steam vessel can be, he has contributed in 1833. And National Board of Fire Underwriters organized in 1866. In 1900, the first safety periodical named Safety Engineering was published. In 1913, Safety Council was found in USA. 1914, during the First World War, the first Safety of Life at Sea convention held in London. And later on in 1919, ILO was established at Geneva in 1921. Later on, ILO contributed a lot for the safety. Now we'll come to the industrial accidents. What are the major industrial accidents happened in the world? ILO, Indian International Labour Organization, estimates 2.3 million women and men around the world has come to work-related accidents or diseases every year. And around 6,000 deaths every single day. It's not a small number. It's a big number worldwide. There were around 340 million occupational accidents and 160 million victims of work-related illness annually. You can see the picture. There are a large, we can say, the worst industrial disasters ever happened in the world. From these disasters only, we learned a lot of things in safety. When an accident happens, everybody thinks about safety. Oh, if safety was there, this accident could have been avoided. The first thing is Opua explosion. Opua explosion occurred in 1921 when a tower around 4,500 tons of mixture of ammonium sulfate and ammonium nitrate fertilizer exploded at a plant at a company called BASF. BASF is one of the largest petrochemical industry now also one of the largest petrochemical industry in Germany. That happened, and that killed around 600 people, and around more than 2,000 people were injured. Come to the Rana Plaza explosion. That was in Bangladesh, Dhaka, 2013. A building, we can say a 8-story commercial building called Rana Plaza collapsed. Total death around 1,200 people died and approximately 2,500 people injured. And it was considered the deadliest structural failure accident in the modern human history, and the deadliest. It was a garment factory, deadliest garment factory disaster in the history. Now we come to the Bensiu Colliery explosion. It has happened in 1942 in China, but during that time, it was during the Second World War. During that time, it was under control of Japan. It was a mine. The disaster began with a fatal explosion, and it was caused by a mixture of gas and coal dust, a fire in the mine. In order to suppress it, the Japanese operators cut off the air ventilation shaft. They cut off the air ventilation shaft, but they forgot to ensure the people were evacuated. Before evacuating the people, they cut out the air ventilation, and this trapped, the people were trapped inside the sealed area, and they suffocated to death as a fire burned of oxygen and produced carbon monoxide poisoning. Around 10 days it took to take the bodies, because there were a lot of debris and all, so take out the bodies from the Bensiu Colliery explosion. And this is a famous Piper Alpha. Piper Alpha is an offshore oil rig platform in Scotland. There was an explosion happened in 1988 and killing around 167 men, and so many people were injured, and some people could escape. Around 60 people could escape and survived, and 30 bodies, dead bodies, could not survive still now. And it was also a deadliest accident in the, we can say it is the costliest man-made catastrophes ever. The cost was around 1.7 billion pound during 1988. And that was one of the worst offshore oil disaster in terms of lives lost and industry impact. Now, if we come to Bhopal tragedy, that was the eye-opening incident in India, happened in 1984, December 3, midnight. It was a Union Carbide Limited company, American company. Methyl isocyanate, that was a poisonous gas, leaks, around, it was in Madhya Pradesh, Bhopal. the world's worst industrial disaster. Around 500,000 people were exposed to the methyl isocyanate, a poisonous gas, a highly toxic substance. And in and around the town, it was a populated area. Madhya Pradesh and Bhopal was a populated area. And around 2,259 was immediate death, and 8,000 people were died within 2 weeks, or 5 lakhs people affected by the chronic illness and all. Even still, if you go there, the water is contaminated around some area. The disaster happened because of the water entered on a tank, because the cooling system was failed. The company was cut down all costly things. The ventilation, the refrigeration system was out of order, and the water entered to that tank. So what is that? Exothermic reaction happened, and a huge quantity of heat released, and the temperature increased, the pressure increased, and the spare tank was not ready, and all standard operating procedures were cut, and the resulting in reaction increased temperature, and inside the tank around 200 degrees Celsius, and the gas was leaked. That was the deadliest ever accident. And even in the Bhopal, the newborn babies are affected. A lot of hereditary problems are happening. So this is the after effect of Bhopal tragedy. And the next one is the Chernobyl disaster. That was one of the deadliest accident ever happened in the world. It has happened in 1986, reactor number 4 in USSR, the old USSR. Now it is in Ukraine, a town, a city in Ukraine, that is Pripyat. Pripyat is a town in Ukraine. It was in old USSR, that is Russia. It was considered the worst nuclear disaster in the history. The Chernobyl releases 400 times more radioactive material than an atomic bomb dropped in Hiroshima. We know during the Second World War, United States has dropped a bomb in Hiroshima and Nagasaki. The radioactive materials were 400 times and that of that. You know, they were using an RBMK reactor. You might have seen the Chernobyl disaster series. A film is there, Chernobyl disaster series. They were running a test. Actually, they were running a test in the morning. In the night, there were a shift change. So the new people may not be, was not much completely aware about the procedure of the test. They have to, the turbine, the reactor number 4 was designed to work at 200 megawatt, 3,200 megawatt power. They have to conduct a test at 700 megawatt. So they were reducing the power. So how we can reduce the power? By inserting the control rod, we can control the chain reaction, we can control the power. And they were reducing the power. Immediately what happened, that power drastically starts reducing to up to 20 megawatt. Then the in the film you can see the master, the Dyatlov, the comrade Dyatlov was advised the subordinates to raise the power. And the subordinate was saying that it is, sir, it is not safe. But this person has some vested interest to complete the test and submit the report to higher authority on that day itself. So his ego and his adamant attitude, and he was saying, I have 25 years of experience. The master says it is safe, it is safe. And they forced to raise the power, and the control rods were removed. 211 control rods were there. Almost except 6 control rods, all control rods were removed. A high chain reaction happened. The power starts increasing drastically. It goes to 3,000, 4,000, 6,000, and the last reading was 33,000 megawatt. The reactor was designed for 3,200 megawatt, but it accelerates to 33,000 megawatt and it explodes. And a Chernobyl reactor exploded, creates a lot of impact. Even now, that area we cannot enter. The radiation is very high. Around some square kilometers, just like a graveyard, we can see in some pictures. That complete area was like a graveyard. So many people died in that accident. So from these industrial accidents, we have to understand the importance of safety. Now, we'll see some, and there are so many other industrial disasters also I have not listed, especially Flixborough disaster, Sevoso disaster, Texas City refinery explosion, 3 Mile Island, Jaipur oil disaster, and recently in India, Visakhapatnam, LG Polymers chemical plant at Gopalpuram, a gas leakage was there. These are the other eye-opening incidents or accidents happened. Now we'll familiarize some safety terms. What do you mean by accident? We never want to be an accident. It is an undesired, unplanned event which may cause personal injury, damage to property or equipment, or loss of output, or all of this. That is called an accident. What do you mean by injury? Injury is nothing but a bodily hurt sustained as a result of an accident. Near miss, we can say it is a warning sign. We can say a simple example of near miss. If you are crossing a road, a truck was just about to hit you, but you escape. That is called a near miss. Near miss are forms of accident which could result in injury or loss, but do not. Hazard, this is a very important term in safety. Hazard means an existing unsafe condition or action, or a situation, or an event, or their combination, which has a potential to cause an accident. The hazard can become a cause for an accident. We can simply say a simple example I can make you understand hazard is nothing but, we have storage tanks. In all industries, we have storage tanks of different inflammable gases or liquids, methane, petrol, diesel, LPG, LNG, all type of inflammable or toxic gas storage will be there. We cannot avoid an industry. We cannot run an industry if this is inflammable. So we have to avoid this. We cannot run an industry. It will be there. Hazard will be there. But a safety officer or safety professional's job is that the hazard should not turn to an accident. It is just simply like this. Hazard is nothing but a poisonous snake. If you are a poisonous snake, we are keeping inside a box. It is hazardous. Poisonous snake is a hazardous thing. When it will become an accident, if the snake comes out from the box and bite you, then it becomes an accident. You will die because of the poison. It is just like that. The storage tank contains tons of inflammable gas or liquids or toxic gases will be there. That should not come out and create an accident. There is the role of a safety professional. Like a poisonous snake comes out from the box and beat you, that time you die, that time it becomes an accident. Like that, a poisonous gas or toxic flammable or inflammable liquids or gases should not come out from the industrial premises. That is the purpose of safety. Now we come to some other. This is another term, unsafe acts. Unsafe act is nothing but it's an act deviates generally from the recognized manner. But generally, we have a standard operating procedure. If somebody is deviating from that, we can say it is an unsafe act. We can say an example of unsafe act is standing under a suspended load. If somebody is standing under a suspended load, improper lifting, starting a machine without authority, maybe use of alcohol, servicing equipment in motion. This all we can say it is an unsafe act. Unsafe condition, another one. This is the existence of mechanical, physical or chemical or environmental condition or situation that cause a hazard and accident. We can say an unsafe condition is nothing but a slippery floor. An oil was slippery. A slippery floor we can say is an unsafe condition. Maybe a rough surface or sharp edges, maybe inadequate lighting, a glare, inadequate ventilation, inadequate warning system, high noise, vibration, all these things we can say it is unsafe condition. Now this is risk. It's a very important term in the safety area. Risk is nothing but it is a combination of probability of occurrence. Probability of occurrence is nothing but frequency. How frequently an accident happen? Once in a year, twice in a year, 5 times in a year, 10 times in a year, or maybe 1 time in 5 years. How frequently accident happens? That is nothing but the probability. How severity? Severity is nothing but, severity of consequence is nothing but how many people died? How many people got fatal injury? How many people got affected by that? So that is a severity. So risk is nothing but it is a combination of probability and severity. Now we come to why we want to implement safety. What is the connection between safety and productivity? Now, all the industries in undeveloped countries, they were not giving much importance to safety. They were not giving much importance to human life at all. But developed countries and developing countries, they are giving much importance to safety because it is as part of the legislation, it is as part of the law. If simply you can imagine, if an industry have good safety, the employees will be highly motivated. Employees will have a confidence that my managing director or my owner is giving me good personal protective equipment, gloves, mask, all the personal protective equipment, good ventilation, good lighting, good facilities, everything it will be given. Automatically what will happen? The people have a tendency to work hard. My owner or my managing director, my CEO is providing me all facilities. Why don't I work? So automatically the productivity will increase. If safety devices are not incorporated over there, what will happen? An accident happen. If an accident happen, what will happen? Executives will get more time to concentrate on productive. Executives will not get more time to concentrate on productive activities if an accident happen. What is their job when an accident happens? They have to go for compensation, they have to hospitalize people, they have to settle out all these things, insurance, so many things will be there. They will never get a time to concentrate on productive activities. If safety is there, they can concentrate on good product, how to maintain quality, they can compete with the same products with some other things. And if safety is there, we can reduce the absenteeism and labor turnover. The person need not to search for other industry. The person need not to go for some other industry. If their industry is taking care of them. And reduction in direct and indirect costs, that we are coming, what do you mean by direct and indirect costs? We are coming to another slide. And it can reduce the damage also. This is the connection. Automatically, safety will increase the productivity. Nowadays, in developing countries or underdeveloped country also taking as a objective, safety is objective. In every industry, if you take the first objective will be profit. Second objective, maybe we can say it is productivity. Third objective may be quality. And they have accepted safety is also one objective. I can say in a simple example, if somebody want to spend 10 lakhs rupees for implementing safety, if he's taking a decision that, 10 lakh rupees I cannot spend for safety, so cut down that in the budgetary. If an accident happened, maybe we have to spend 10 crores rupees to settle an accident. A costly equipment may be damaged. So many people might have died. We have to give compensation and so many other things. And there may be infrastructural damage. We have to clear out everything. So 10 lakhs, if we could have spent, we could have avoided that accident. To compensate that, we have to spend 10 crores. So which one is better? Spending 10 lakhs or spending 10 crores? So 10 lakhs we can spend for safety. You can at least save so many lives. What is the causes for accident? When an accident happens, so many people try to find the reason and blame somebody. People who are working in safety field, they might have a feeling that if an accident happens, everything will be under the head of safety department or safety professionals. If anything good happen, so many hours of accident-free, so many million hours of accident-free happen in industry, so many people will come and take the credit. If anything wrong happen, this person will be the culprit. So this culture has to be changed. What will be the major reasons for an accident? The first reason is taking the shortcut. If you take the disasters, Chernobyl disaster, Bhopal tragedy, all that, they were taking the shortcuts. They were taking the shortcut. They were not following the standard operating procedure. So taking shortcuts without going for the standard procedures, if you are bypassing something, that will be the major reason for causing an accident. Being overconfident, we have seen in Chernobyl, what is his name? The Dyatlov. The comrade Dyatlov, the senior engineer over there in the control room was ordering that subordinates raise the power. When he was refused to raise the power, I have 25 years of experience. I am saying, raise the power. What was the reason he ordered like that? Because he was overconfident. He might have done so many things unsafely, nothing might have happened, but the next time you will be the victim. So overconfident is another problem. Starting the task with incomplete instruction, poor housekeeping. Japanese people have introduced a new method for proper housekeeping. That is 5S concept they have introduced. That is very good for housekeeping. Like a house, you can keep your industry safe. Ignoring safety procedures, mental distraction. This is another area we will do another webinar on this industrial psychology. What are the factors which affect the human brain? If a worker comes to the office by making quarrel in the house, he was quarreling with his wife, he was quarreling with a neighbor, and he have mentally distracted, he's coming a cutting operation he was doing. Imagine he's doing a cutting operation. When he is doing a cutting operation, he might have a chance to commit an accident. So mental distraction is another. failure to accident. Now, what is the impact of industrial accidents? So you can see what are the impacts in Chernobyl itself. You can see what is the impact of industrial accident. The environment is polluted. The loss, so many people died. Damaged flora and fauna, air, soil, water, everything polluted, and financial losses to industry. These are the impacts of industrial accidents. We came to a famous theory that is called accident causation theory, and it was introduced by H.W. Heinrich. He is considered as the father of safety. H.W. Heinrich, he is considered as the father of safety. And he evaluated a theory that is called domino theory. You can see he has observed around 330 incidents. In the 330 incidents, 300 incidents were resulted in a near miss. There was no injury, just escaped. 29 incidents were resulted in minor injury, and only one was resulted in a fatality or major injury or life loss. From this, he has analyzed injury is because of an accident. An accident is happened because of an unsafe act or unsafe condition. Unsafe act or unsafe condition is because of a fault of a person, carelessness. And carelessness is because of the social environment and ancestry where he born and brought up. The situation where he born and brought up. I can say a simple example to you take an undeveloped country, there was no rules, regulations, stringent. You take a country, for example, if sorry, I'm taking a country, Bangladesh. Please excuse me if anybody from Bangladesh or some other African countries, their rules and regulations are not up to the mark. You take a developed country where the rules and regulations up to the mark. You take a Germany or France. Imagine at 6 o'clock early morning, somebody was riding a bike, riding a motor vehicle. In a junction, there was a signal, red signal is there, countdown 60, 59, like that, it goes on. There was no vehicle. It is early morning. What was the tendency of a Bangladeshi? What was the tendency of a German or French? I'm not blaming Bangladeshi. This is normal things happen because of the behavior and because of the social environment where he born and brought up. The Bangladeshi or a African person have a tendency to cross the line even the red signal is there because nobody is there. He have a inborn tendency to violate the rules because he have violated the rules many times. Nothing happens. But a French or German, there are the safety regulations or rules are followed strictly. He will wait for until the red turns to green. That is the difference of social environment. Safety is not a slogan. It should become a culture. It's very important. We have to, it is all of a sudden it will not happen. It will take so many years. Developed country also took so many years to become like that. Then only that big countries will become developed. Developing country also slowly, India also taking so many actions on camera fixing and on controlling the violations on traffic rules. Fine. Slowly it will come. If you ask a American person or a German, a developing country person, have you ride the bike without a helmet? They say no. If you ask me, I have ride the bike without helmet. That has to change slowly. If a person taking the bike, immediately his brain give a sense or brain give a information that he has to wear the helmet, then only he will put the key into the ignition. That should be a culture. It will slowly nurture when the country grows. These laws and rules, regulations, and that make you safe, that make you comfortable, that makes you the happiest environment. So he has found out that, and he has found out in 100%, 98% of the accidents can be preventable. Only 2% of the accidents cannot be preventable. That is because of the natural calamities, earthquake or volcano explosion or tornado, something like that. In this 98%, 88% of the accidents are because of unsafe acts. And only 10% of accidents are because of unsafe conditions. So, which is the most contributing factor to an accident is unsafe act of a person. So in that context only, so many theories has contributed to behavior-based safety. We can study on industrial psychology, the behavior of a person, and by changing the behavior slowly, we can avoid so many unsafe acts, and we can avoid so many unsafe act, and we can avoid accidents. If we come to the major industrial hazards are fire, explosion, and toxic gas release. In fire itself, we have jet fire, pool fire, flash fire, and blevy. What do you mean by the jet fire? You can see in the picture jets. A jet fire is a specific type of fire that occurs when a high velocity fuel leaks from a pipeline or from a tank, and it got ignited immediately. Then it will result a high pressure release of gas with a limited size of openings from a pipe or flange or maybe a valve, a tank, that can result in a jet fire. The parameters that can influence the flame shape are maybe wind speed, the material properties, the atmospheric conditions. All these things are the things affect the jet fire. If you consider the pool fire, you can see in the picture pool fire. This is also a common type of fire which can occur in the form of a tank fire or from a pool of fuel spread over a ground or water. Maybe you can see, suppose a ship containing crude oil or any type of inflammable liquid. It leaks into water, it forms a pool, and it got fire. We can say it is a pool fire. We have different pool fire modeling by using TNO model. We can pool fire and we can identify the heat radiation or radiative flux. We can estimate the radiative flux, heat radiation, heat release rate. All these things we can find out. Heat flux we can find out by using different pool fire modelings. And the pool, the heat depends upon the pool diameter. If pool diameter increases, the heat also increases. Now next is a flash fire. It is also known as a vapor cloud fire, a combustion of flammable vapor and air mixture in which flame passes through the mixture, and at a less than sonic velocity, a flashover takes place, a sudden it is not a sudden flash fire gas burns, and the temperature may be up to 500 to 1000 degrees Celsius. Now if we come to the blevy, blevy is nothing but boiling liquid expanding vapor explosion. This is happen, from the picture itself, a compressed or liquefied natural gas or LPG, liquefied petroleum gas, if we say, it is liquid, it is compressed, or we can say it is made at a liquid level and the gas is there, it is pressurized. If suppose there is a leak, maybe a rupture of vessel or pressurized liquid above its boiling point leaks, and what will happen? A fire happens. So if fire happens because of the temperature, the liquid inside this vessel or a tank starts evaporating drastically, very fastly. What will happen? It emits gas. The pressure inside the cylinder will increase. That will operate the pressure relief valve. Maybe if the pressure relief valve open, what will happen? The gas immediately escape. So that creates a vacuum, or that creates a space. That space, what an immediate action happen is the rate of converting liquid to gas will be very fast. If very fast reaction happens over there, and an enormous amount of liquid is converted to gas, and that pressure cannot withstand the container, then it will explode. That process is called boiling liquid expanding vapor explosion. And another hazard of this is projectile hazard will be there. The parts of the cylinder will throw it away to 1 to 2 kilometers. That is called projectile hazard. And this type of accident only happened in Mexico City in 1984. Happened, petroleum LPG gas cylinder, LPG gas spear. Blevy happened, and around 600 people were killed over there. Around 5,000 people were injured. Severe burns happened because of this blevy. And the sudden containment failure allows a superheated liquid to flash, and it increases its volume over 200 times. This is sufficient to generate a pressure wave to fragments, and if there may be a fireball can happen. So these are the types of fires, and we can model the fire by using different type of modeling. Now we come to an important point, is risk. As we have discussed, the risk is nothing but it is a combination of probability and severity. How to reduce the risk? We have to assess the risk, then we have to reduce the risk. That we are going to see. So this is a function of probability and severity. And if we see the risk assessment, first we have to identify the hazard, and then we have to go for the scenarios which leads to an accident. Then we have to estimate the accident frequency. We can estimate the how frequently the accident happens. Once in a year, twice in a year, like that, how frequently accident happens. Then we have to go for a consequence analysis, and we can estimate the risk. Now, hazard identification, we can use different tools can be used for hazard identification. The commonly used tool is HAZOP. Hazard operability study is the commonly used tool for hazard identification, and checklist can be used, what if analysis can be used, task analysis can be used, and Dow is an American company. They have introduced fire explosion and toxicity index, FETI. Fire explosion and toxicity index can be determined. These are the hazard identification techniques. Mainly hazard identification and risk assessment techniques can be classified into two categories, that is qualitative technique and quantitative technique. That we will explain in some other webinar. That is also a detailed topic. After hazard identified, then we have to go for risk assessment. Risk assessment techniques are fault tree analysis, event tree, board type, barrier diagram, reliability data, human reliability, consequence model. These are the things can be used for assessing the risk. Now, if you see this picture, this is the risk process. First, as I told you, we have to identify the risk events, which initiating event for the risk. Maybe for a fire and LPG, the initiating event may be a leak. What is initiating event? How frequently it happens? What is the reason for this initiating event? How the leak happened? We have to find out all that things. After identifying this, we can have the risk impact assessment, the probabilities, all these things we have found out, and consequence. If a gas leaks, what will happen? If we can say a dispersion of gas, a toxic gas or inflammable or flammable gas. It can be, the typical incidents that might include the rupture or a break of a pipeline or a hole or a tank or pipe or external device, etc. That can be, will be the accidents begin with like that. And, the vapor cloud. We can classify the vapor cloud into three categories: positively buoyant gases, negatively buoyant gas, and neutrally buoyant gases. Negatively buoyant gas means the density of that type of gas will be greater than the air, so it will come down. The positively buoyant gas means the density of that gas will be less than the air, so it will go up. Neutrally buoyant gas will be stagnant like air. And the duration release. So the duration of the release is instantaneous, maybe a puff, or continuous release, maybe time release. And this dispersion of gases, depends upon the atmospheric stability, the wind speed, the local terrain effects, maybe the buoyancy of the material, the height of the release above the ground. These are the parameters which affect the gas dispersion. Anyhow, we have to prioritize the risk. Which point or which initiating event has the major contributing factor, or which has the highest risk probability, or which has highest risk consequence, and we have to prioritize. Then only we have to take a decision. After prioritizing the risk, what we want to do is, after prioritizing the risk only, we have to go for risk mitigation. Additional protective layers can be added, thereby we can mitigate the risk. Now, this is the hierarchy of control. How we can reduce the risk? There are first we have elimination, substitution, engineering control, administrative control, and PP. These are the hierarchy of control. How we can reduce? First thing we have to go for reducing the risk is elimination. A commonly used example of eliminating hazard situation, we can say if suppose somebody was doing a work at a height, how we can eliminate? Convert that work in a ground level. Working at a height increases the risk. Then we have to take the work, moving the work to ground level eliminates the falling hazard. We can eliminate like that. Come to substitution. How we can substitute? Typical example of substitution is nothing but replacing a solvent-based paint. We can replace a solvent-based paint with a water-based paint. What is the problem with the solvent? Solvent is inflammable. It can get fire. So solvent is substituted by water. So that is substitution. Engineering control, if the machine, moving parts with the machine can be guarded, that is an engineering control. We can have fencing around electrical switchgear. We can have, a simple example is fume hood to contain, remove or airborne hazards. Placing barriers around the fans, noisy equipments, reducing sound levels. This all we can say engineering control. Administrative control is nothing but it can be provided to people. People can be rotated, or maybe they include procedures. Good warning signs can be included, labels. People can be get trained. Administrative controls do not eliminate hazards, but resist, assess to those hazards, use of procedures and rules. Now, if last one is the PPE. PPE is nothing but personal protective equipment. We can classify the PPE into two categories: respiratory and non-respiratory. Non-respiratory PPEs are the PPEs used for protecting head, helmets, safety hats, or protecting the eyes. We can use safety goggles, safety spectacles, maybe face shield can be used, gloves can be used, aprons can be used, safety shoe, gum boots. All this can be used for this thing. That is comes under non-respiratory. Respiratory. If suppose somebody want to do an operation in the confined space, if somebody want to do an operation in the confined space, they can go for respiratory breathing apparatus, air purifying apparatus, chemical filters, mechanical filter, or combination of chemical or mechanical filter, or maybe air inlined, supplied air or air inlined apparatus, or compressed SCABA. That is self-contained breathing apparatus, SCABA. These are the things can be utilized for confined space where sufficient oxygen is not available. We have to use this type of PPE. Now, if we've come to the ALARP, ALARP is a concept that after estimating the risk, we have to identify whether the risk comes under in which region. You can see a red color, yellow color, and green color. Red color indicates it is intolerable region. This risk is intolerable. Somehow we have to reduce the risk or stop the operation. That is, second one is ALARP. ALARP is okay, allowable, as low as reasonably practicable. That is a full form of ALARP. As low as reasonably practicable. It is tolerable region. It's somewhat okay. And the safest region or broadly acceptable region is green. So after risk assessment, we have to identify whether the risk is in which region. If the risk comes under the top, that is intolerable region, we have to add additional protective layers. Simply, I can say, if a room does not have any, or any particular hotel does not have any smoke detector, fire extinguisher, heat detector, flame detector, nothing is there. If suppose a fire happened in a hotel room due to short circuit, because of the furniture, everything, the fire will get ignited. No, in the night, nobody knows. It got exaggerated like anything, and in uncontrollable situations, so many people may die. So risk is very high. How can we reduce the risk? We can install fire alarm. Fire alarm circuit can be added. Smoke detector can be added. Smoke detector is added in the initial stage itself. Smoke detector will detect and it will give a warning sign. Thereby we can extinguish the fire. So thereby we can, increasing the protective layers, we can reduce the risk. And if you see this is a risk matrix. You can see impact. Impact is nothing but severity. Likelihood is nothing but the frequency. If the impact and the frequency is very high, then it comes under high. It is a risk is very high. The impact is somewhat medium, so it is medium. And impact is reduced. Frequency is also reduced by incorporating safety mechanism. We can say the risk matrix, the risk is very less or low. Now, the 5 E's of accident prevention. First is education and training. How we can reduce or prevent accidents? We can educate people. Education and training is to prevent unsafe acts. We have studied 88% of the accident caused because of unsafe acts. So we can educate people. This is the most powerful remedy to for unsafe acts. It helps finding out unsafe condition also. Workers can be given training, understanding of specific hazard, safety rules and safe procedures, training for a difficult job, job safety analysis, safety instruction for variety of jobs. All these things can be done. So thereby educating and training, we can avoid unsafe act. If we come to the engineering control to prevent unsafe condition, engineering control, we can say if suppose a poor illumination or ventilation, unguarded machinery and all. Some engineering controls are substitution of less hazardous material or risk reduction, or maybe providing a guarding or fencing, maybe a safe design, including safety fire alarms, maybe a tripping device, a safety valve, NRV, non-return valve, and maybe a PRV, pressure return valve, EFV, that is excess flow valve, FFV, firefighting equipments, etc. can be installed, and we can have an engineering control. Next is enforcement. Enforcement is the duty of a policing, just like a policing. Here in India, we have a factory inspectorate. Factory inspector come and check the industry at any time. If he found that it is, they are not following the standard operating procedures, they are not following the rules and regulation, he have the authority to stop the process. He can seal the factory. So that is the enforcement. So they have to go and check the industry whether it is goes on as per the rules and regulations, and they have to. Next is enthusiasm. How we can make enthusiasm to people? We can give some. It should be come from the top management to the lowest worker. It will keep workers safety conscious. It can be developed by proper safety attitude, competition. We can conduct a competition. We can give award. We can give prize. We can give appreciation letter. So this includes motivation and participation. And the last one is example setting. I can say a small example of example setting. When I was doing a project, engineering project in one industry, it was a compressor manufacturing industry. I can say the name also. It was LG, ELGI. It was a compressor manufacturing industry. I went to the industry in the shop floor. The worker was wearing a ash color shirt and a navy blue color pant. In the back side of the shirt, it is written in orange color ELGI. I thought this is the uniform of the worker. Now I met a supervisor. He was also wearing a uniform. Then I thought that supervisor worker level, this is the uniform. Then I met the manager. I was surprised. Manager was also wearing the same uniform. And then I was moving out of the plan. I saw the general manager was sitting over there. General manager was coming out from his room. He was also wearing the same uniform. When the general manager came out, and suddenly somebody was saying that the managing director, the CEO, the owner of the company is coming. So I was waiting, eagerly waiting. A Benz car came, a white Benz car came. I was waiting to see the managing director, who is the managing director, who is the CEO of the company. A surprise, that managing director, the CEO, the company CEO, the owner of the company was also wearing the same uniform. That was an example setting to create a uniformity. Or the top executives and managers has to take the health and care of the lower people, workers. They have to be as an example setters by self-enforcement of safety rules, of uniformity, then others follow them. This is a chain of reaction to increase and maintain safety. Now, how we can measure the safety performance? The two questions usually asked is, the question number one, how frequently, how often the injuries occur? The answer is frequency rate. We can estimate the frequency rate by using this formula. And number two, how serious are the injuries? How severe? That can be answered by using this formula. Man days loss due to lost time injury into 10 power 6 divided by man hours worked. Now we come to the cost of accident. Just like iceberg, we always think when if we see the iceberg, my thought is always goes to the Titanic. Stop sharing. Enter screen. Now, when we see the iceberg, my thought is always goes to a Titanic. When a Titanic ship sink because of hitting an iceberg, why he could not see? Because the visibility of the iceberg, only in iceberg we can see the 15 or 10 to 15% was only visible. Remaining 80 to 85% was below the ground. The direct and indirect cost is just like that. The direct costs is very less, but indirect cost is very high. The cost of an accident. If an accident happened, the direct cost includes the compensation paid to the injured worker, maybe insurance premium, maybe the hospital charges and all that things. That's all the direct cost. But indirect cost associated with an accident is huge. In developed countries, it is estimated that 5 to 8 times the direct cost. Indirect cost is 5 to 8 times than the direct cost. It includes cost of wages paid for working time lost by injured worker, cost of wage paid for working time lost by other workers other than injured worker, net cost. If an accident happened, other workers, they will continue the work? No. Other workers, they leave their job and they will try to hospitalize the injured worker. So what will happen? The operation is stopped. Everybody leave their job and they will take to hospital, and so there will be an ideal time. So that is the cost. It next cost, repair or replace the material or equipment. Particular machine may be damaged. You have to replace it. Extra cost due to overtime work necessitated by an accident. Cost of wage paid to supervisors. Wage cost due to decreased output of injured worker. And cost of learning period and preparation of new workers. Uninsured medical costs. All these things comes under the indirect cost. So we have to reduce all these things by preventing an accident. Now we come to the legal aspect of HSC. These are in India, Indian Factories Act, we can say it is heart or brain of all laws, which is to ensure the safety. Indian Factories Act 1948. Indian Factories Act 1948, the first amendment came in 1987 after the Bhopal tragedy. A new chapter, Chapter 4A, hazardous material management, was added after the Bhopal tragedy. So you can imagine the impact of an accident or disaster. So Indian Factories Act and the Disaster Management Act, Explosive Act, Petroleum Act, SMPV rules, Boiler Act, Employee Compensation Act, MSIHC, Material Storage and Import of Hazardous Chemical, Environmental Protection Act, BOCW Act, that is Building and Other Construction Workers Act. These are the main act in India. And what is the responsibility of a safety officer? If you want to become a safety personnel or safety professional, what is the job you have to do? The safety officer's first job is to implement the policy, safety policy, OHS, Occupational Health and Safety Policy and Programs. Carry out JSA. JSA is nothing but job safety analysis. We have to find out the reason for an accident. A particular accident is repeatedly happening, we can conduct a JSA, job safety analysis. We have splitting the sequence of operation into small pieces, and we are analyzing separately. Thereby, we can find out the reason. Then organize the workshop, seminars, campaigns, competition, all that things. Then advise the purchase department to ensure high quality PPE. I have seen some one place, there was a helmet, some no, broken by falling an object from the top. The quality of the helmet is not good, then what is the purpose of wearing a helmet? So we have to advise the purchase department to ensure quality of PPE, carry out plant safety inspection, carry out accident investigations. Why accident investigations are conducted? Accident investigations are conducted not to blame anybody. That is the principal purpose of accident investigation, to find out the cause. Why we want to find the cause? Similar accidents can be avoided if we find the cause, and we can take a precautionary actions. Conduct risk assessment, promote setting up of safety committee, that is very important. Check if all employees are acting in adherence with the rules and regulations. Now, in India, who can be a safety officer? According to law, what is a qualification required to become a safety officer? A person holds a bachelor's degree of engineering in safety and fire engineering, BTech, safety and fire engineering, plus 2 years experience, he can become a safety officer. Or if a person has any engineering degree, maybe BTech, chemical or electrical or civil or mechanical, he has to do, or maybe a person with a bachelor's degree in physics or chemistry, plus 2 years experience he has to do a 1-year diploma in industrial safety engineering provided by Central Labor Institute. That is as part of DG FASLE. DG FASLE means Directorate General of Factory Advisory Service and Labor Institute. DG FASLE. There is a Labor Institute. Central Labor Institute is in Mumbai, and RLIs are in Faridabad, Chennai, Kanpur, and Kolkata. They are providing a diploma. They have to complete that 1-year diploma, or state government recognized 1-year diploma in safety and fire engineering, safety engineering has to be completed. Then he can be designated as a statutory safety officer. He can be designated, or a 3-year diploma plus 5-year experience plus this 1-year diploma provided by all these institutions can also be a safety officer. Now, what are the international certifications? We always talks about NEBOSH. What is NEBOSH? NEBOSH is nothing but a National Examination Board for Occupational Safety and Health. It is from UK. You can easily complete a NEBOSH IGC. NEBOSH is providing general and international general certificate in occupational health and safety, and they are providing fire safety and risk management, construction health and safety. NEBOSH HSC certificate in process safety management is also there, and international technical certificate in oil and gas operational safety, certificate in environment management, diploma or international diploma in occupational health and safety and environment management. And NEBOSH offers a master's degree also in collaboration with the University of Hull, MSc in occupational health and safety, environment management, and all. And next you can see this is the CSP, Certified Safety Professional. This is one of the highest qualification, American qualifications for to become a safety professional. You can become a safety, high manager level, or in the vice president, something like that. You can go certified safety professional. For to get CSP, for to appear CSP examination, you should have a 4-year bachelor's degree. For an engineering degree, you have plus 2 years experience, and you have to complete either any one of these, that is ASP, Associate Safety Professional, or Graduate Safety Practitioner, Transitional Safety Practitioner, or even maybe NEBOSH IDIP, maybe our India diploma, or any certificate, diploma or diploma certificate provided by the state government or CLI, RLI. Then you can write the CSP examination. So for writing the CSP examination, you should have a bachelor's degree. In addition to bachelor 2 years experience and bachelor's degree, plus any of this, that is BCS, ASP, GSP, TSP, or CSP, or diploma, international diploma in occupational health, that is NEBOSH International Diploma in Occupational Health and Safety, or our Indian CLI, RLI diploma, or state government diploma, or maybe CMIOSH. CMIOSH is nothing but Chartered Member of Institution of Occupational Safety and Health. that is also possible, or CRSP, Canadian Registered Certified Professional. Any of these qualification will work out. And British Safety Council is also providing a level 3, level 4, level 6 diplomas. IOSH is also a Institution of Occupational Safety and Health is also a certification, IOSH certification, Health Safety Executive, HSC, UK HSC. They are all providing safety certifications, internationally accepted safety certifications, CSP, NEBOSH, all this, CRSP. CRSP is nothing but Canadian Registered Safety Professional. These certifications, completing after the certification, you can become a safety professional. Now, if you want to join for any UG or PG programs in safety, in PG you have a program. This is a well-known program, International Master of Science in Fire and Fire Safety Engineering. This is jointly conducting by these 6 universities, and is Gent University, Belgium, then the University of Edinburgh, UK, Zurich University, Switzerland, Lund University, Sweden, the University of Queensland, Australia, University of Maryland, United States. In addition to this, there are so many universities offering undergraduate or graduate or postgraduate program in safety, disaster management, risk assessment. University of Central Lancashire, Oklahoma University, Ulster University, United States, University of Sheffield, UK, Memorial University, Canada, University of Malaya, Malaysia, Auckland University of Technology, New Zealand. These are the universities providing. University of Sheffield is providing process safety and loss prevention, MTech or MSc, in Masters in Process Safety and Loss Prevention, and also Hazards and Resilience. These are the 2 courses University of Sheffield is providing. So these are the universities providing, the famous universities. And in India, we have MTech, Master of Technology in Industrial Safety, is provided by so many colleges, NIT, UPS, School of Engineering, CUSAT, and all these institutions providing this course. UG program, that is BTech, Bachelors of Technology or Bachelor of Engineering in Safety and Fire Engineering or Fire Technology and Safety, is provided by UPS, University of Petroleum and Energy Studies, Dehradun, School of Engineering, Cochin University, Tokach Institute of Science and Technology, I belongs to that institute, National Fire Service College, Nagpur, and these are the other institutes providing BTech or Bachelor's degree in Safety and Fire Engineering. Now, research areas. What are the research areas we can have in safety? Now, this is the firefighting suit. You can see a firefighting suit, a material development. A hydrogel, the heat resistance increases. You can see there are different layers, the outer layer, the moisture barrier and thermal layer. We can have an additional layer of hydrogel can be added to this, thereby we can increase the heat resistance, or we can go inside the inside a fire compartment and we can evacuate people, and we can withstand more time, maybe 2 to 3 minutes, 2 to 5 minutes we can. So the time can be increased by additional layer in this fire suit. There are researches are going on this. Now we have a pool fire modeling. Now we have an experimental setup. We can create an experimental setup for open pool fires by the equipments like IR, infrared thermometer, K-type thermocouple, heat flux sensor, a pan and anemometer. We can model it and we can find out the heat radiation, heat flux. We can blend a different type of fuel, petrol, methane, mixture of different blending, and we can study the flammable characteristics of different pool fires and experimental setup. And the risk assessment is a very vast area. The problem in risk assessment is that accurate accident data normally required for risk analysis is unavailable. Underdeveloped countries that doesn't have a proper reporting system. Underdeveloped countries, and so we have to look for expert judgments, and expert judgment will be different. One expert judgment will be different than other expert judgment. So, which makes the risk incomparable. So, in this context, we can use a fuzzy logic. It's an important method where there is a lack of data and a lot of uncertainties and complexities in risk can be solved by using this risk fuzzy logic method. So first what we are doing, we are taking fussification, and if then rule can be made, then defussify, and we can take the crisp output. We can add fuzzy logic with all the risk assessment method like fuzzy fault tree, fuzzy FMEA, failure mode effect analysis, fuzzy FMECA, fuzzy HASOP, fuzzy LOPA, fuzzy Bayesian, fuzzy risk matrix, all these things. And also we can have optimization techniques like an optimal risk identification. We can find out the maximum risk at a particular process or a particular failure mode by using simulated annealing, taboo search or neural network, genetic algorithm, particle sum optimization, hybrid algorithm or tunicate sum algorithm. These are the different optimization methods can be used for optimizing the risk, Bayesian network and all. Now we have the flammability of solids. Flammability of solids, UL94 test. Underwriters laboratory test flame spread in solid. We can use colorimeter tests to calculate the HRR, heat release rate, and modeling using pyrosim and the thermogravimetric test, differential scaling, calorimetric to melting point, glass transition temperature can be found out. And the pyrosim, the softwares related to safety and fire engineering, pyrosim and fire dynamic simulator. Pyrosim is a leading software accurately working with FDS models. Pyrosim is a graphical user interface for fire dynamic, and we can find out HRR, heat release rate, peak HRR, convective flow currents, radiation flow, conduction heat flows, thermocouple temperature flows, all these things. And also FDS, fire dynamic simulator, fire driven fluid flow computer program solves numerically a large eddy simulation form of Navier-Stokes equation appropriate for low speed thermally driven flow with an emphasis on smoke and heat transport from fires to describe the evolution of fire. And the FDS software is developed by the National Institute of Standards and Technology in cooperation with the VTT Technical Research Center. And this is another Aloha and FAST. This is also used. Aloha is nothing but area location of hazardous atmosphere. So we can find out the dispersion of gas in this picture using Aloha and FAST. Based on wind direction, we can find out what is the concentration of the gas at this point up to which is the safe distance. We can find out if a dispersion of this much size, 1.2 kilometer, the concentration is 5 milligram per meter cube, and orange, you can see this is the 1.6 kilometer, then 2.9 kilometer, yellow is 2.9 kilometer. Like that, we can have a dispersion software like FAST, processor analysis software, and Aloha, area location of hazardous atmosphere software, can be used for analyzing the dispersion of gas. And maybe by using FAST, we can find out the individual and societal risk also. Now, this is the end of that, and I hope we could start from the basics to up to the research things, what is happening in the safety and fire. It's a noble profession, I should say. We used to say to the students that a doctor can save only one life at a time. By removing a cancerous thing or by doing a surgery, he can save only one life at a time. But a safety professional can save thousands of lives by preventing an accident. So such a noble profession is this. It has a lot of humanity and a lot of nobleness. So anybody can choose this profession as a safety officer or safety professional to save human life and save humanity. Thereby the country will progress and prosper, and the citizens of the country can make them happy and safe. Thank you.